6-3, dividing fractions. 6-1 was simplifying. 6-2 was multiplying, and now we are dividing. And notice that they introduce multiplication and division before addition and subtraction because there's less work that's needed. When we multiply and divide, we don't need common denominators. You'll see in 6-4 where we have to write equivalent fractions, which equivalent fractions involve multiplication, hence why we are building that skill first. So division is exactly like multiplication. The only difference is we are going to convert the division to multiplication. So we are going to take the reciprocal of that right term of the denominator, and then that'll convert it to multiplication. So very simple, very straightforward. So always the first thing to do is convert the division to multiplication by taking the reciprocal of the right term. We could continue on with our prime factorization. We're going to put those. This is a form of cross-canceling that we're doing here. We are, let's do 2 and 8. We're finding common factors, 8, 5, and that leaves us with 5/2. You could have just done it straight up from here. You could see that 8 goes into 16 twice, 5 goes into 25 5 times. What we definitely are not doing, we will not multiply across. We will not do 8 times 25, which is 200. And we will not multiply 5 times 16, which is 80. That is no. That is a big no. We're not going to build it up just to break this down. Then we would look for factors. Well, it's a whole lot easier to look for factors when they're broken into factors. Notice how we were able to break up 25 and 16 to factors. Good. So we will be moving in that fashion as we go along here. 4, 8, 3, 9. We're left with 2/3. A/10 times 2/a. The a's will cancel. The 2 is divisible as a common factor, and we get 1/5. And these are good practice. I know that this seems very rudimentary and very simple, but just getting these and doing them and just having them under your wing is really important. So it's just very good practice. It makes sure that you don't make silly mistakes. You can't leave it as 6/1. You must simplify 6. I'm finding that a lot of students now in 8th grade, their simplification skills are very weak. They don't have an understanding that they need to simplify fractions. For some reason, that is not enforced in the lower grades, but reducing fractions and not writing it as 6/1 or 5/10, those things need to be simplified. No high school math teacher is going to allow you to leave a fraction unsimplified. So these are basic, simple. We can cancel the ends. We can cancel the 4 with the 8. And you see that I like circling things, and that's a visual. That's just so I see what is left over. Oftentimes things can get lost in it. So you could remember, write it as this and put it over, and then we can see the true canceling and what we're left with. So sometimes that's a little bit easier. I'll mix up that format every now and then just to see what's working. We have 3 times 3 times C times D over 3 times C times C times D. And now we can see that we're going to cancel the 3's. We can see we're going to cancel the C's and the D's. And now it's very easy to see what is left over. So there's no circling and sort of shuffling of stuff. 2x squared over 3y times 9 over xy. Another mistake that students will make is when they convert from division to multiplication, they will take the reciprocal of the left term. That is incorrect. That is in the numerator. Your denominator is going to be the term. Denominator, what do you mean? Well, when we see this, we know that it can be written like this. And notice, this looks like it's in the numerator, but we know it's in the denominator. So that's why we take the reciprocal. Because it was in the denominator, we have to place it in the denominator. That's the logic behind all of that. 2 times x times 3 times 3. All I'm doing is taking the prime factorization of my numerators. And that is going to equal 3 times x times y times y. I'm going to write it, maybe not, maybe I won't. I guess I don't always put it in standard form or. Then what are we going to cancel? We're going to cancel the x's. We're going to cancel a 3. That's not a lot. That's 6x over y squared. So not very much canceled there. 3n over 4m squared. Now here's another thing. I could, and then I decided not to. So 3n times 4 times 3 times n over 4 times m. My 4's are going to cancel, and m is going to cancel. Whoop! Not that one. Oh, isn't that? How did that? M is going to cancel, and that's it. Nothing else canceled. I almost got ahead of myself. 9 n squared over m. Attention to detail. Don't go so fast that you're going to make silly mistakes. This is a good one. So if this is x, if that's in the numerator, it's a whole number, so it's in the numerator. The reciprocal would be 1 over xy. And one of the x's is going to cancel with one of those x's, so we're just left with x. The y's will cancel, which gives me x over 2. 8a squared over 3b times 1 over 4a. Again, that's a fraction. The 4 will cancel, the a will cancel, and that's it. So 2a over 3b. These are good. These are, oh yeah, whoa. All right, so orders of operations. We have 2 operations here. We have division and we have exponent. So we're going to do the exponent before we convert it, the division, to multiplication. So I'm going to distribute that to each of the terms. So that's 2 squared, x squared, 3 squared. So that's 1 divided by 4x squared over 9. Now I'm going to convert by taking the reciprocal, and that just gives me 9 over 4x squared. Good tricky one. I like that. We'll do that again. Distribute. In first, 9 divided by 3 squared n squared. 9 divided by 9 over n squared. 9 times n squared over 9. That 9 is in the numerator, cancels with that 9 in the denominator. N squared. 16 divided by 2 cubed, a cubed. 16 divided by 2 cubed is 2 times 4 times 2 is 8, a cubed. 16 times a cubed over 8. 8 is in the denominator, 16 is in the numerator. That goes 2 times, and we're left with 2a to the third. So we're not really far along at all on this. There are lots of practice problems. Well, and here we go. Ask and you shall receive. So now we got a little bit more going on here. So I'm going to look at things and I'm going to rewrite them to prepare me for the next step. So now I'm not going to cancel just yet. I'm going to factor because I can't cancel things being added and subtracted. Remember, the reason why we factor is because now this is multiplication. And when we can multiply, we can cancel. So 6 times 9 over b plus 1. So the b plus 1s can cancel. The 6 and the 9 can cancel, but 6 doesn't go into 9. It just has a common factor. Another issue that I see many students struggling with. So what goes into 6 and 9 is 3. 3 goes into 6 twice. 3 goes into 3 3 times. And now we are left with 9 over 2. And we can leave it as an improper fraction. So I'm going to factor this as I go. I'm going to factor out a 2n minus 1 over 8n times 24 over 2n minus 1. 2n minus 1 cancel. We'll do the 2 and the 8. We'll do the 4 and the 24. And that leaves me with 6 over n. And there we go. We'll factor that. That's the difference of squares. Hopefully you are getting better at noticing or recognizing the difference of squares. X plus 2, 3, and that leaves us with 3 times the quantity x minus 2. We don't have to distribute out. We can just leave that. That's the difference of squares. 3x times 6 over x minus 4. And this is what the benefits of doing all of these problems, the repetition, is that we get really good at our foundational work. And this is foundation. This isn't advanced. This is not advanced stuff. This is the most basic, rudimentary, beginner algebra that you must know moving out of 8th grade. I keep telling my students that, but I don't know if they believe me. They will, but hopefully they will put the time in. X minus 5. 4 goes into 12 3 times. Nothing else cancels. We're left with 3 times the quantity x plus 5 over x. And also important, students, is that when something doesn't make sense, when you are watching a video and you don't understand, or because the teacher just assumes that you know what they're doing, you need to ask questions. You need to take the time to come in and ask questions and ask for clarification. They are more than happy. They are willing. That's their job. That's what they want to do. That's why they do what they do. That negative represents -1, so that's a fun question. But that's why they're here. They love when students ask questions. Now you got to do your work. You just can't come in and go, I don't know what I'm doing. You have to have work to present so the teacher can look and see and say, oh, I see you're doing this. Here, you need to fix it by doing this. We're going to factor out a -3. Remember, anytime we have a negative as our first term, we're going to factor out a negative. We'll factor out a negative here also. And I always like making sure that when you redistribute, that it equals this starting expression. So make sure that's a nice, easy, quick check for students to do. Now we're going to cancel. A minus 2 is easy. What goes into 4 and 6? 2. 2 goes into 4 2 times. 2 goes into 6 3 times. And that is all we're left with. So we have 2 times -4 is -8. -3 times 3 is -9. We cannot leave that. The 2 negatives need to cancel to make 8/9. That one's a sneaky one. That one's a sneaky one. We'll factor out an x. We'll see that that's the difference of squares. We'll change division to multiplication by taking the reciprocal of the right term. And now we will cancel denominators with numerators, denominator with numerator. And that leaves us with x over x plus 2. Those x's cannot cancel because of they're being added. Factor out of 3, a minus 4, times factor out of 2, a minus 4 over 1. A minus 4's cancel. You're left with 2 over 3. These are nice, good. This workbook is super good because lots of things can cancel, and they make you aware of each of your little nuances. Yeah, difference of squares there with 2 variables. You should be just as proficient with 2 variables as you are with 1 variable, x minus y. This x will cancel with one of these x's, and we're left with 3x over x plus y. 4 over difference of squares, n minus 4, n plus 4, times n plus 4 over factor out an 8, n minus 4. Oh, ooh, that's not fun. That wasn't fun at all. That didn't cancel very much. That's a 2. So this is how we would write this. We'd write 1 over 2 times n minus 4 quantity squared. That's the best way to write it. I would assume because it's the same binomial, you write it as a binomial square. You don't have to simplify it, but you should do binomial square. All right, now we got some trinomials. And look, we're going to expect you to do it mental math. So much like this, we need to recognize that that's the difference of squares, and that's the difference of squares. We should, and we're going to convert it, so this denominator now goes in the numerator, and we should see that that's going to be x plus 3, x minus 2, and then this becomes x minus 3, x plus 2. My signs are different. Bigger is negative in this one, bigger is positive here, and so we should be able to do those. X minus 3 is going to cancel. No, x plus 3. X minus 2 is going to cancel, and you're left with the quantity x plus 3 quantity squared over x plus 2 quantity squared. I wonder, yeah, I wonder, or could you have done x plus 3, x plus 2 quantity squared? I think you could do that. Yes, that's an interesting way. I don't know. Be interesting to see how they do that. That's going to be plus 5 minus 4. That's going to factor out a 5 to get x plus 5 times difference of squares over x minus 5, x plus 1. Let's start canceling. X plus 5, x minus 5, and that's it. We get x minus 4, x plus 5 times the quantity to over 5 times the quantity x plus 1. Not that many things canceled there. Difference of squares. Ooh, I like this. X minus y, x plus y. This does not cancel. You cannot factor it. That's the addition of squares, which is nothing. That's going to be 1 over x minus y. So that will cancel, and that's it. Students will want to try to make this cancel with its denominator. It cannot. That is your answer. That's going to be, lots of students will overcook that problem. They will think that there is more to do than really is. Minus 3 plus 2. This is going to be different, or this is a binomial square. Ooh, I'll even write it like that. Just so we can see what cancels. So this is going to cancel with one of these. That's going to cancel, and we're left with x minus 3 over x plus 1. Can you do it this fast? Are you this efficient? -2, -1, because the signs are the same and they're both negative. Signs are the same, both are positive, so it's just the same, just with both signs positive. We're going to factor out an 8. We're going to factor out a 4. And that cancels. That cancels. The 4 cancels with the 8. And that's it. 2 times the quantity x minus 1 over x plus 2. If you could be this proficient coming out of 8th grade, you're going to absolutely crush your placement test. And you will be able to show that you are ready. Well, you're ready for Algebra 2, but you'll have to take geometry first. X minus 2 cancels. X plus 2 cancels. All right, here we go. This is good. Finally, a nice whole number. Difference of squares. That's the difference of squares. We're going to multiply, factor out an 8. We're going to factor out a 4. And the plus 5 cancels. The minus 4 cancels. The 4 cancels with the 8. We've seen this before, but you can't do enough of these. 56 years old, and this is still really good practice. Good one here. Difference of squares. Can you tell me what the 2 binomials or the conjugates were? Also, oh, I don't like that. That's not very nice. So I'm going to do something that is somewhat untraditional. I'm going to do that. I'm going to also rewrite that denominator in the numerator. I'm going to keep that. And I'm going to take out these negatives because I always want to be stickler about the negative in standard form. So I'm going to factor out a negative. I get x squared minus 4y squared. And then I'm going to factor out that negative, and we get x minus 2y over 2x minus y. Let's do this. Let's just get these out of the way. They're going to cancel. Let's just, oh well, let's keep canceling. This will cancel and this will cancel. And now let's factor this. We can still, that's the difference of squares. So we made a little bit less stuff to write. 2x plus y times x minus 2y over, and this is going to be the difference of squares, x minus 2y, x plus 2y conjugates. All right, these canceled, that canceled, that canceled. Let me write that in red so students know. Now, what else can cancel? This can cancel. That's it. 2x plus y over x plus 2y is my final answer. Oh, baby, let's go. Last couple. This is x plus 2, x plus 1. Ooh, this is x plus, nope, minus. Ooh, I did that wrong. Those are minuses. Signs are the same, and they're both negative. Signs are the same, both negative. So that's minus 2 minus 1, which makes minus 3. And this is minus 5 and minus 2, which makes minus 7. This is x. The signs are different. Bigger is negative, so that's minus 5 plus 1. And this is the difference of squares. All right, that's a good one. Minus 1, cancel. Minus 2, cancel. Minus 5, cancel. Minus or plus 1, cancel. Oh, wow. I mean, if you look at that starting problem, you would not think the answer is 1. That is so cool. What a good problem. Good job. Good job. Houghton Mifflin. I think that's, or no, McDougal, Littell. Those are the publishers. X, signs are the same, both are positive. X plus 5, X plus 3 makes 8. We got X minus 7, X minus 2 makes negative 9. We have X minus, no, plus 3, X minus 2 makes positive 1, and we have the difference of squares. Cancel. Whoa, not that many things cancel. Cancel, cancel. You're left with X plus 5, X plus 3, X minus 7, X minus 3. That is my answer. Last one? Oh, okay. So you would probably do A times C. I'm finding factors of 2, factors of 3. 2x and x, those, it's prime numbers. So the choice is, does the 3 go here and the 1 go here, or does the 1 go here and the 3 go here? Since the signs are the same, this is going to give me 6 plus 1 is 7, and the signs are the same and both are positive. So that's the quick way of doing it if you don't want to do A times C. Again, we have 2 binomials. It's a prime number. So these are the only factors of 2. So those are the only choices. I have no other choices. It has to be 2x and x. That's the only way you can get 2x squared. Now the 2 on the last, right, this is a product. This is the multiplication of last times last in your FOIL. The question is, does the 2 go here and the 1 here, or does the 1 go here and the 2? So you just need to find positioning. And that's going to be determined by what you need to get. Since the signs are the same and they're both positive, we know this is going to be plus plus, and we need it to be 5. So that's 4 plus 1 is 5. If I had done the other way, 2 and 1, we would have gotten 2 and 2, which is 4, which doesn't equal my inside. So that's sort of the whole thing that we're doing when we factor. We're just looking at what are the binomials that produce it. This is easy. Signs are different. Bigger is negative. So factors of 30 when subtracted equals 7. Well, that's not 15 and 2, 3 and 10. 3 and 10, hello. 10 and 3, 10 is bigger, so that needs to be the negative to get negative 7, because negative 10 and positive 3 makes negative 7. Same thing here. We have x's, signs are different. We have 40 is 6, 2, 3. What do I want to say? 4 and 10, hello. Minus 10 plus 4, because it needs to be negative 6. Now we can start canceling. Negative 10s, 2x plus 1. That's it. Boo. X plus 3. X plus 3 quantity squared. Let's be smart and write our work efficiently. X plus 2, X plus 4. That is my answer. Nope, not our last one. This is our last one. So we're going to do this pretty fast. Plus 6, x minus 1. We have x minus 5, x plus 4 times x minus 5, x plus 3. And we have x plus 3, x minus 1. X plus 3's cancel, minus 1's cancel, minus 5 cancels, and that leaves us with x plus 6 over x plus 4. All these problems should be able to be completed in less than 60 seconds. That's your goal. Can you meet that goal? Can you reach it? Can you be at that level of mastery where you can crush these problems as fast as that? Good job.